So we are solving inequalities using addition or subtraction for a second day. So we know we are using inequality signs, right? And we will solve this for a second day. So this is where we're at today, right here. Okay, day 2. Transforming real world situations into an inequality. Everything is an inequality today. So rather than having an equation, we'll have an inequality. Inequality signs will be visible. Julia read the first 14 pages of her book. She wants to read at least 80 pages by the end of the week. So jot that down. And then we are going to transform that to a math inequality. And then we'll solve it. This is such a basic inequality that I kind of hesitate in using Queen Fiona. But what is the question? Let's go ahead and use it. What is the question? We don't even really have a question, do we? I guess, could you make a question for this problem? What would the question be? Bella?
How many problems, how many pages does she need to finish by the end of the week for each day? Like,
how many pages to reach her goal or something, right?
Yeah.
Let's add that because it helps us in writing this inequality. Okay, so we have the question. The Q stands for questions, and the question is always our unknown. So what do you think would be a good unknown for this problem? Anybody want to give me what you think would be a good unknown? A variable, a good variable for this problem.
P.
P, why did you say P?
Those pages.
P for the pages, good. What are the facts? What do we know? Give me one thing we know. Lindsay.
That she read 14 pages.
Already read 14, okay? And then the other fact that we know, Sophia.
She wants to read at least 80 pages.
So I guess we could say she needs a total of 80 pages. 80 pages. Is there any unnecessary fact here? And we are always looking for numbers that are unnecessary. Anything unnecessary? Does anyone see it? Raise your hand if you see it. What is it, Nika? No, there is no unnecessary. Because that's not a number, is it? I mean, I guess if you were trying to figure out the number of days in the week or something, that's not what we're being asked, right? Okay. We'd be able to use this. Outhouses, right? So is there an operation you can think of that would be useful? Or sometimes at this point we just try to write the inequality or the equation, depending on what it is. She wants to read at least, she wants to read at least 80. I'm going to fix that. Total 80, or is it just exactly 80?
I say yes.
Could she read less than 80 and meet her goal?
No.
Could she read more than 80 and meet her goal?
Yes.
Okay, so there is some sort of an inequality sign here. It's not just equal, right? It could be 80 and it could be more, you're saying. So how do we write that inequality? If you could be more than, or you could be 80. Sophia?
P is greater than or equal to 80.
So it's a greater than or equal to, right? Good. The pages, the total pages, she's saying, have to be greater than or equal to 80. But this isn't going to give us the whole equation or inequality yet because we know she's already read a few pages, right? So that has to be put into this somehow. So everybody try hard, put it down. What is it? Where will you put? Is more than one way to write this? There's more than one way. What's one way to write it, Tatum?
8 plus 14 is less than or is greater than.
Okay, let's test this out to see if this makes sense. Because remember, we talked about you've got to confirm that it's reasonable, right? This is reasonable. So how would we solve this inequality that we've written?
You subtract 14.
Subtract 14. And when you do, you get P is still greater than or equal to what remains?
66.
66. Okay. So give me one solution of this inequality. What is one solution? What's one number that is true in this inequality here? Michael.
68.
He says 68. Does everyone agree that that's true?
Yeah.
68. Is 68 greater than or equal to 66? It is. 68 is. So let's try that back in the original story. I'm going to try to raise it up if I can. 68. So if she reads 68 pages and she already read 14, would she meet her goal of 80 pages read that week?
Yeah.
Very good. So it works. It's reasonable. Okay? 66 is also another solution that works, isn't it? 66, we know, plus 14 is 80 pages exactly, so it works. Okay? See if you can change these inequality or these phrases into inequalities. These are inequalities, okay? Can you change them? Do I have a volunteer? Number 28. Okay, Jimmy, number 28.
Okay. I think I'm gonna go P.
All real numbers less than 4. P is going to represent the all real numbers, right? All real numbers, we'll call those P. All the real numbers that are less than 4. Thumbs up if you agree. Woo. Lots of thumbs are up. Very good. All real numbers less than 4 is P is less than 4. Any variable would work, right? Okay, next one, Tessa. All real numbers greater than negative 10. All real numbers greater than negative 10. I heard her say P is greater than negative 10. Whoop, she's fixing it. P is greater than negative 10. And thumbs up. Very good. And number 30, Anthony. You're close to the board. All real numbers greater than 19. Who has it down already? Very good. You just want to have it down and check your work.
This is easy peasy.
Very good. Easier than the last word problem. Let's try one more word problem just to make this interesting, and then you'll be on your own. Ready? Y'all ready? Anyone need more time? Okay, here we go. Ooh, yes, a beautiful word problem.
Oh my gosh. Look at him.
You know what? You are going to face a number of these in your assignment today, so you don't need to write this whole thing out. You can find this on page 287. 287. So you may look there and you may read here as well. Multiple step problem. Page 287. Is everybody there? Okay, Lauren can spend at most $75 at the mall. She plans to buy a backpack for between $25 and $35. She'll spend the remaining money on gifts. So let's let X represent the cost of gifts. Can you write and solve an equation, it says. An equation to find the least amount Lauren can spend on gifts. So when you come across that question, question A, what's one symbol we know we need now because of what is written here? What's one symbol we know we need? And it is, right? A symbol that we need. We might need a variable. I'm looking at these words. Write and solve an equation to find the least amount. So we need what, Lindsay?
An equal sign.
An equal sign. It says equation. So we're in this section on inequalities, but we're doing an equation right now. You see that? Because it says she can spend at most 75. It says write and solve an equation to find the least amount Lauren can spend. The least amount she can spend. How are we going to find the least amount she can spend? I mean, let's think about, she has $75, right? She has $75 and she needs to buy this backpack. The backpack will range from $25 to $35. So if she spends $25, how much money does she have left for gifts?
50.
If she spends 25, she has, do you see that? 50, right?
Oh, yeah.
Left for gifts. But what happens if she buys a more expensive backpack? Let's let everybody think. And what is left? 3, 2, 1.
$40.
Okay, so write and solve an equation to find the least amount she could spend on gifts. Have we written an equation to show that?
No.
No.
We haven't?
No.
What's the least amount she has left after buying her backpack? Everybody see the least amount is here. We just answered question A. If she buys the cheap backpack, what's the most she has left? And so this answers which question? Those who are looking ahead? Question B. Good. Okay, so could she buy a different priced backpack?
Yes.
Abby, what other price might she pay? Something between 25 and 35. So that could change things, right? It would change the amount of money she has left for gifts a little bit, okay? But part C says, describe the possible values for X using inequalities. And remember, X is right here, it meant the cost of the gifts, right? So the gifts can cost anywhere between what and what? Right? $40 and $50. So how can you write that as an inequality? The gifts, X, are the gifts, right? Can be anywhere between 40 and 50, or how would you write that? Sophia?
Could it be X is greater than, greater than or equal to
She says X is greater than or equal to, she's wondering, which one could it be greater than? Could it be greater than 50 or could it be greater than 40? 40, good, very good. Or the other inequality, or the other piece that's missing, Michael?
X is less than or equal to
50. Okay, but so there's a little bit of a limit to this. If we go greater than 40, we can't go over 50, right? So I wonder if this is a bit challenging. This is how they leave the answer because we're still at kind of a basic level of inequalities. Could anybody put these two inequalities all into one statement? This is an advanced topic. This is actually an algebra topic. But if X can be greater than or equal to 40, but it needs to be less than or equal to 50, could you make this sentence into a 3-part sentence?
Yeah.
How could you do that? Let's see if you guys can do this advanced. 3-part question, or 3-part statement. Nico.
X is greater than or equal to 40, which is equal to,
Which is,
equal,
X is,
which X is less than or equal to.
very good. Good job. There it is. You see how that is a true statement? All of the values for the gift must be between $40 and $50. So this is a 3-part statement. It's kind of cool. And we'll get into those next year. Okay? Very good. You are going to now work on this assignment.
Can I get on camera?
Have fun.
Can I get